Welcome to the Deep Dive, the show that's your express lane to being well-informed. We take a stack of sources, pull out the most important nuggets of knowledge, and deliver them with just enough surprising facts to keep you hooked.
Exactly.
Today, we're plunging into the fascinating and, frankly, essential world of network switching, specifically focusing on the critical commands you need for Aruba CX switches.
Yeah, some really foundational stuff here.
Okay, let's unpack this. We're drawing our insights from practice questions designed for the HPE7-A08 exam.
Right, the Aruba CX Switching Associate Exam.
But let's be clear. This isn't just about acing a test.
No, definitely not.
This deep dive is your shortcut to truly understanding the core fundamentals of network management and troubleshooting.
That's the real value, absolutely.
Whether you're a seasoned pro looking for a quick refresh or intensely curious about what makes networks tick, you're going to walk away with truly practical knowledge.
And hopefully a few aha moments, as you said.
I guarantee it.
That's absolutely right. While our source material is framed around exam prep, the commands and concepts we'll explore today are, well, they're the bedrock of reliable network operations.
Right.
It's about understanding the why behind network behavior and being able to quickly diagnose and respond to issues.
Which is invaluable, really.
It is. Regardless of your technical background, these aren't just commands. They're, the language of your network.
Exactly. And our specific source material today is derived from HPE7-A08 exam, Aruba CX switching commands, packed with exam basics and critically detailed practice questions with explanations that really bring these concepts to life.
Those explanations are key.
So before we dive into the commands themselves, let's briefly set the stage. Just quickly, what's the context for this HPE7-A08 exam?
Sure.
For those considering certifications or just curious, it's a proctored exam.
Yep, supervised.
You're given 2 hours. Seems pretty generous.
It is, but there are 75 questions to get through.
75 questions.
Okay.
So about a minute and a half per question. And you need a 65% to pass.
That's the benchmark, yeah.
And it's offered globally.
English, Japanese, and Latin American Spanish.
Got it.
That structure, 75 questions in 2 hours, it really underscores the comprehensive understanding required for effective network admin.
It's not just memorizing commands then.
Exactly.
Yeah.
It tells us success isn't just about memory, but truly grasping the interplay between various components and how they impact the network as a whole. It's a holistic view.
Which is what we're aiming for today.
Precisely.
Absolutely. So let's jump straight into a scenario. Imagine you've just walked up to an Aruba CX switch.
Okay.
Maybe it's brand new, maybe users are complaining it's acting weird.
Classic.
The first thing you need is a rapid assessment, right? A quick pulse check.
Yeah, where do you even start?
Exactly. How do you get that immediate snapshot of what's going on without getting, lost in a sea of data?
For that immediate health check, your absolute best friend is Show Interfaces Brief.
Show Interfaces Brief.
Okay. Think of it as the network's executive summary. This command gives you a concise overview of all interfaces.
Like which ports are plugged in and working.
Kind of. It shows their administrative status. Are they turned on in the config? And their operational status. Are they actually up and running?
Oh, that distinction's important.
Crucial. It also shows IP assignments, if any, and the link status. What Show Interfaces Brief really tells you, beyond just up or down, is that immediate state of negotiation.
Negotiation.
Yeah. If you see an interface administratively up but operationally down, that's a key insight. It means your switch is trying to bring the link up, but the other side isn't responding, or maybe the cable's bad.
So it immediately narrows down the problem.
Instantly. You're looking at the peer device or the physical connection, not necessarily an internal switch issue. Saves so much time.
That's a powerful shortcut for connectivity. But networks aren't just cables and signals. What about the box itself?
The physical well-being. Good point.
What if the switch is, literally overheating or running on dodgy power?
For the switch's literal vital signs, you need Show Environment.
Show Environment. Makes sense.
This command is your direct line to the hardware's health report. It displays the status of all power supplies, fans, temperature sensors.
The physical guts of the thing.
Exactly. If a fan fails, or a power supply isn't providing power, or maybe it's getting too hot, Show Environment it'll scream it at you.
You want to know that stuff before things go sideways.
Absolutely. Its importance can't be overstated. A network device's reliability is entirely dependent on these components: cooling, power. If they're failing, everything else is just waiting to follow.
Okay, so Show Interfaces Brief for connections, Show Environment for the hardware health.
Right.
But if users are still complaining about general slowness, or you see intermittent issues that don't seem tied to one link, Where do you look first for those, like, deeper performance bottlenecks?
If you're chasing down those more elusive performance issues, or maybe just curious about what's eating up the switch's brain power,
Yeah.
show processes is your command line magnifying glass.
Show processes. Okay, CPU usage.
Exactly. It shows real-time CPU utilization, but broken down by individual processes running on the switch.
Ah, so you can see if one specific thing is hogging resources.
Precisely. I've often seen situations where maybe a misconfigured routing protocol or like excessive logging is just silently chewing up CPU cycles.
And that can cause slowness everywhere.
It can. This command lets you quickly pinpoint any process consuming excessive CPU. It's often the first indicator of a software-related performance issue or even some kind of abnormal behavior.
So it's not just for fixing problems, but maybe spotting them early.
That's a great way to put it. Tracking CPU usage proactively can definitely help to detect potential issues before they escalate.
Excellent. So we've established a solid baseline, checking connections, hardware health, and CPU load.
Good first steps.
Now let's shift gears a bit, from general diagnostics to the specific flow of data within your local network. Layer 2 stuff.
Okay, AMAC addresses VLANs.
Exactly. So continuing our scenario, if that switch is acting up, or maybe you need to verify who is connected where for security,
Yeah.
how do you pinpoint which device is on which port?
Ah, playing detective. For that, you'll reach for Show MAC Address Table Interface.
Show MAC address table interface. A bit longer.
It is, but very specific. This command filters the switch's MASI address table. That's its internal address book, basically.
The mapping of MS to ports.
Right. It filters that table to show only the entries learned on one particular interface you specify.
So if I want to know what's plugged into port 10, I run this command for interface 10.
Exactly. It's incredibly useful for troubleshooting connectivity. Does the switch even see the device's MASI address on that port?
Or is it plugged in somewhere else? Or not at all?
Precisely. And for security, it lets you quickly check if, say, an unauthorized device popped up on a port, or just track down where a specific user's machine is connected.
So the MFC is fundamental for layer 2 forwarding.
It is. It tells the switch where to send frames locally.
Okay, so once we've identified who's connected, the next crucial step is often segmentation, dividing the network up.
For security and efficiency, yeah.
How do we assign devices or ports into those different segments?
That's where virtual LANs, or VLANs, become indispensable. The command here is actually a configuration command, interface VLAN.
Interface LAN, used in config mode.
Right. You'd go into the configuration context for a specific interface, like interface 1110, and then you'd use the command, maybe FLAN access 100, to put that port into VLAN 100.
So you're assigning the port to a VLAN.
Correct. It directly places the interface into the desired VLAN, effectively creating isolated broadcast domains.
Like invisible walls, you said.
Yeah, that's a good analogy. They segment traffic, which improves security keeping departments separate, for instance, and they boost efficiency by limiting broadcast traffic.
So broadcasts and one VLAN don't flood the others.
Exactly. Now, interface LAN assigns the port, but the real magic often happens later with interVLAN routing. You need something, usually a layer 3 interface on the switch, to let those VLANs talk to each other when needed.
Otherwise, they're just isolated islands.
Right. But assigning the port is the first step.
Okay, segmentation is powerful, definitely critical, but I remember hearing horror stories about network loops.
Oh, yeah. The broadcast storm nightmare.
When you have redundant paths, which you want for resilience, right? What stops data just circling endlessly and grinding everything to a halt?
You've hit on one of the most critical layer 2 challenges. And that's precisely where Spanning Tree Protocol, or STP, steps in.
STP. Heard of it. How do we check its status?
To see what STP is doing, you use Show Spanning Tree.
Show spanning tree. Got it.
Think of STP as like a vigilant traffic controller for your layer 2 network. It dynamically figures out where there are redundant paths.
Loops.
Potential loops, yeah. And it logically blocks one of those paths to prevent the data from circling endlessly.
But it keeps it ready as a backup.
Exactly. If the primary path fails, STP unblocks the backup route. Very clever. The Show Spanning Tree command displays a global STP status across all interfaces.
What does it show specifically?
Crucial details, like which switch is the root bridge or the center of the STP world, what role each port is playing, forwarding traffic, blocking traffic, or being the root port and its current state.
So you can verify it's actually working and preventing loops.
Absolutely essential. Without STP, or if it's misconfigured, even one accidental cable plugged in wrong could bring your whole network segment crashing down.
Yikes. Okay, critical stuff. So we've got our local network lockdown, HAMI-C addresses, VLANs, loop prevention with SDP.
Handling things nicely inside a switch or segment.
But how do we boost capacity and reliability between switches, or maybe to important servers? More than just one cable can handle.
For that, we turn to link aggregation groups, or LAGs, sometimes called port channels or trunking.
The lags, so bundling cables together.
Basically, yes. Think of lags as transforming multiple single-lane roads into a multi-lane superhighway for your network traffic.
Okay, I like that analogy.
Instead of one cable being a bottleneck, you bond several together. This doesn't just multiply your bandwidth.
It also gives you redundancy, right? If one cable fails.
The traffic automatically reroutes over the remaining cables in the AG. It's seamless.
Nice. How do we check if the UG is set up correctly and working?
To verify their setup and operational state, show lag detail is the command you need.
Show lag detail.
This command provides the complete configuration and status. It shows which physical interfaces are members of the L, their individual statuses, the hashing method used to distribute traffic across the links.
Hashing method.
Yeah, how it decides which cable to send a particular traffic flow down needs to be consistent on both ends. It also shows any errors or mismatches.
So really important for troubleshooting if a lag isn't performing well.
Absolutely essential. It lets you inspect every single lane on your digital superhighway, make sure they're all open and carrying traffic properly.
Fantastic. Scaling up local connections and adding resilience.
Okay.
Moving beyond those direct connections or aggregated connections. How do switches know where to send traffic for networks they aren't directly plugged into? Now we're getting into routing, layer 3.
Right, the art of routing. For basic routing, especially to specific networks where the path doesn't change often.
Like maybe the route to the internet gateway.
Exactly, a classic example. Or maybe to a specific partner network. For that, iproute is the command.
Iproute. Also a configuration command.
Yes. On Aruba CX switches, this command is used in configuration mode to create a static route in the routing table.
You're manually telling the switch how to get somewhere.
Precisely. It's like drawing a specific map instruction. You specify the destination network address, its subnet mask, and then the IP address of the next hop router, the next device the switch should send the traffic to.
So packets for this network, send them to that router's IP.
You got it. This tells the switch exactly how to forward packets to networks it's not directly connected to. Static routes are invaluable for simple designs, specific connections, or even as controlled backup paths.
Solid for predictable paths. But what about larger networks? Things change, links go down. You need something smarter, right?
Absolutely. When your network is constantly evolving or you need automatic resilience to failures across a bigger enterprise, static routes become hard to manage.
That's where dynamic routing comes in.
Exactly. And for many, OSPF Open Shortest Path First is the gold standard interior gateway protocol.
Okay, OSPF. Here's where it gets really interesting, as you say. How do we verify that those intelligent routing decisions are happening? That the switches running OSPF are actually talking to each other correctly?
Great question. For dynamic routing with OSPF, the command you'll rely on heavily is show Appleoff neighbors.
So Appleoff neighbors.
This command displays detailed information about all the active OSPF neighbors the switch has formed a relationship with.
Neighbors meaning other routers running OSPF
Yeah.
that it's connected to?
Correct. It shows their router IDs, their current state. Like, are they fully adjacent or still establishing the connection and the adjacency status itself?
Why is that so important?
Because OSPF relies entirely on these stable neighbor adjacencies, these healthy conversations, to exchange routing information dynamically. If those adjacencies aren't formed right, or if they flap up and down...
The routing information doesn't get shared properly.
Exactly. Your network won't learn routes as expected. You end up with connectivity black holes. This command is absolutely crucial for confirming that those OSPF neighbor relationships are up and stable.
Giving you confidence that your network's dynamic intelligence is actually working.
Precisely. Peace of mind.
Okay, wow. We've covered a lot of ground. From physical hardware checks
Show environment.
to interface status,
Show interfaces brief.
CPU load,
Show processes.
layer 2 detective work,
Show MAC address table interface.
interface VLAN,
Loop prevention.
show spanning tree,
Boosting bandwidth.
show lag detail,
And then into routing, both static. IP route.
and dynamic with OSPF neighbors.
Show IP OSPF neighbors. Whew.
Yeah. But before we wrap up, there's one more. One foundational command that might seem small, almost an afterthought maybe.
I think I know where you're going.
But it has huge implications for everything else we discussed. Logs, security events, troubleshooting.
You're absolutely right. That unsung hero is accurate timekeeping.
Yes. And the command.
The command to verify this critical function is show NTP status.
Show NTP status.
Yeah.
Network time protocol.
Exactly. This command verifies both the configuration and the operational state of NTP on the switch. It shows if the switch is synchronized to an NTP server, which server it's using, how far off its clock might be.
Why is this seemingly simple thing so critical?
Imagine trying to troubleshoot an issue across 5 different switches, and all their log timestamps are minutes or even hours apart.
Nightmare. You wouldn't know the sequence of events.
You wouldn't. It's truly critical for accurate timekeeping across your entire infrastructure.
So what does this all mean for you, the listener? Accurate time sync, verified by show NTP status, is kind of the silent guardian of everything else.
That's a good way to put it.
It ensures your security logs are sequential and trustworthy. Vital during a breach investigation, right?
Absolutely vital.
It makes sure authentication processes that rely on time work correctly.
Curb Barrows, for example, is very time sensitive.
And it's just indispensable for correlating events when you're troubleshooting complex problems across multiple devices. If your clocks are off, your whole picture is skewed.
It turns a simple problem into a potential wild goose chase.
Thank you for joining us on the Deep Dive. We hope you've enjoyed this exploration of Aruba CX switching commands.
I hope it was useful.
Until next time.